Hi, my name is Alvin Jiang. I am turning into a high school junior, and I'm currently participating in STEM Teachers NYC. Today, let's discover the amazing opportunities STEM Teachers NYC provides.
STEM Teachers NYC is a teacher-led nonprofit organization in New York City that organizes workshops for STEM educators across the region. STEM stands for Science, Technology, Engineering, and Mathematics. A majority of the participants of the workshop here are teachers. To help teachers understand how to best reach their students in STEM subjects, the workshops introduce a brilliant method called modeling instruction and communicates this by placing participants in the role of both student and teacher. In student mode, the participants think and discuss like if they were students. Then, in teacher mode, teachers talk about how to create a productive and interesting classroom, which is usually really hard to work on. The workshop that I attend is called Computational Modeling in Physics. This workshop takes place in Trinity School, New York. Throughout the 3 weeks in this workshop, we explored how to combine high school physics with the use of computer programming to illustrate some key concepts and challenges. Most subjects in physics were explored in the workshop. For example, the conservation of energy, constant velocity, acceleration, forces, and more. To fully understand and to hear different opinions on these concepts, we used a technique called whiteboarding. In this section of the workshop, participants formed groups to write on their whiteboards about their thoughts and some examples of a concept. Here's an example. In order to understand the conservation of energy, a group of us interpreted energy as batteries in a house. The batteries could be in different places in a house, just like energies could be stored in different forms. Anyway, the amount of the batteries stays the same in a house, just like the amount of energy remains the same in the system. This form of illustration is really fun, and it further helped me to understand the concept. As I mentioned before, computer programming is another subject we focused on. We used a coding language called Pyret to explain numerous topics in physics. Pyret is developed by Bootstrap Physics with the purpose of assisting students' algebra study. We used Pyret to simulate the motions of moving objects. This is a simple program we ran in Pyret. We compared the difference in motions of two runners with different velocities. All the contracts, the examples, and functions related to this problem are listed on the left of the program. After hitting the run button, we can see that the runner on the bottom started 2 meters in front of the runner on top. But because the top runner had a greater velocity, they ended up at the same spot on the 3rd second, and then the top runner takes her lead. We can also click on the image to reveal the motions of these two runners. Through the studying of Pyret over these 3 weeks, I learned one interesting fact about functions. They must have inputs, and according to the recipe you designed, the computer responds to the output accordingly. One example that especially helped me to realize this point was the transferring of units in temperature. This is also a program we coded on Pyret. Basically, it consumes the input of temperature in degrees Fahrenheit and produces the output of temperature in degrees Celsius. The function is called temp f to c, and the contracts were written on the left, and let's run it. As what we can see from the function, the input of 0 degrees Fahrenheit gives you negative 18.7 degrees Celsius, and the input of 88 degrees Fahrenheit gives you 30.932 degrees Celsius. Once again, computational functions require the inputs, or the variables, and they produce the outputs, aka the outcomes. In my perspective, the use of a computational model to solve scientific problems is an example of teaching with modeling instruction. To conclude, modeling instruction is helpful for STEM studies because it inspires students to develop and work with actual visual models in order to explain some of the key concepts people might otherwise be confused with.
3 weeks before school starts, so vacation and family time. During the school year, I plan to definitely incorporate Pyret into my physics classroom. Definitely incorporate parts of modeling. Since I'm relatively new to the modeling curriculum, I'm not going to do it all at once. There's a lot of pieces of my pedagogy that would be changing, and so my plan is to do a decent amount of Pyret, some of the modeling concepts, and use those pieces of this workshop to help my ninth graders learn physics next year. A lot of valuable things. I would say 3 pieces that I'll describe. The first is just the opportunity to talk to other physics teachers. So I'm the only physics teacher in my school. I don't necessarily have a built-up community of physics teachers yet in my career. So it's a great way to talk to other physics educators, get challenged on physics problems, learn what else is going on out there, so I'm less operating in a bubble. The second piece is the modeling piece. And a lot of what modeling does, I've been trying to do intuitively with my classes, and now I have a vocabulary and a way of articulating those things. And then the third piece is computational modeling. Last time I coded was 10 plus years ago in college. Not a fan of coding by myself, not a fan of dealing with error messages. I really wanted a supportive environment where I could have people help me through those things and get my feet back in the water and get swimming again, so to speak, with that. And so all 3 things were really phenomenally well done in the workshop.
I think since this is still a relatively new project, every time we get a chance to run this with more teachers, we get to see more ways that it can be implemented in classrooms. I know personally I've added a handful of new simulations, so just getting more feedback from teachers and how they would run things in their classroom, the kinds of activities that they like, is always beneficial. What I'm really hoping, and what I think would really help this project in the future, is if we can get these teachers to the level where they're developing their own materials and their own simulated activities. I think that's how we really get a sustainable base of materials for these, rather than just us on the curriculum development team making up activities. So I'm really hoping that we can get some of these participants to come up with their own activities.
Thank you.